This is House Planning Help episode 89. Hello, I'm Ben Adam Smith, and this is the podcast for you if you want to build a new home or remodel an existing property. I'm exploring what houses we should be building in the 21st century. My personal goal is to create an energy efficient home before I turn 40 in August 2016. Coming up in this session, my guest is Bjørn Kierulf from Kierulf. We're aiming for the bullseye today. Can you have a durable Passivhaus standard home that's been built using natural materials? And if yes, why isn't everyone doing it? If this is the first time you've downloaded one of these podcasts, fantastic. Thank you for coming along, and I hope what you hear today will be useful and will make you decide to listen to more or perhaps delve back into the archive. It's one of my goals, as you might have just heard, to build my own house, but I must admit, it's at the stage of the process where I'm quite frustrated, and I'm only really at the beginning looking for land. I feel I've done lots of research and I need to be moving it on, but it's easier said than done. I'm in a location where I would like to stay. It's a nice town in the UK. The trouble is the land around here is very expensive and non-existent. Well, that isn't totally true. The developers seem to be able to get hold of that, and that's largely big plots. So I think I'm at the stage now where I'm deciding maybe I have two avenues that I need to explore. I've done a few things. We put a bid in on a property which we really liked. Maybe we should have gone all out to get it. It just seemed a lot of money. But perhaps I'm going to try this to turn it into a bit of a local news story. That way, getting the word out that I'm looking for land, and also chronicling what must be a regular problem when people come to self-build in these types of situations, that they can't find land and they probably just give up in the end and just go and buy a house that's already on the market. It's not that there isn't land, as I've already said. The volume house builders seem to get hold of it and can keep on building. There have been huge developments here in the town of Hertford. So it's not that there aren't new houses coming onto the market. It's just that they've got it all sewn up. And that's why the other route that's perhaps a bit scary, I'm not sure that I'm ready for this yet, would be to acquire a bigger plot of land and then divide it up and find some fellow self-builders. At least I'm creating a podcast that potentially there could be other people you might be thinking, well, I'd love to come and live in this area if there's a plot that's affordable. So that could be the other way of just looking for bigger plots of land, which I think might be more doable, and then dividing those up for self-builders. But as I mentioned, that would be hugely scary. I don't even know what I'm doing on building one house, so why would I want to get tangled up in all of this? Anyway, a few thoughts to let you know where I'm currently in the process and getting concerned about reaching my goal of building this house in over a year and 3 or 4 months. Let's move on to our featured interview with Bjørn Kierulf from Kierulf. They're based in Bratislava, Slovakia, and built with all sorts of lovely materials: straw panels, wood, limestone bricks, clay plasters, and the list goes on. And Bjørn is very well respected, actually, because of these buildings. They get that balance right, where not only has the construction phase got a tiny carbon footprint, the materials all have low embodied energy, but then the building lasts for decades, and when you finish with it, well, it just goes back into the ground. And all that, and you've got an ultra low energy building while you're using it. So this is really the holy grail. Can it become a reality? We're going to find out. Let's get going. I started by asking Bjørn to tell me a little bit about his background.
Well, I have my wife is an architect. I'm just an industrial designer. So she was interested in doing something that makes sense. So we looked around, looking at different materials, different ways to build. So in fact, we started with natural materials before we started with Passivhaus.
Where do you start? Are there any natural materials that are better than others?
Well, most natural materials are fibers. And they have fairly good insulation value for thermal comfort, especially also in summer. They have good protection against overheating as well, better than most like fiberglass insulations or other light insulations. So these fibrous materials are in fact very user-friendly for what we need to do. The problem is that, of course, we have to protect them against humidity, moisture, but that applies, I think, to all kinds of materials.
But this is going to be harder or not so if you approach it in the right way?
Of course, you won't get as thin an insulation at the moment as you would, let's say, with some artificially made materials. Maybe aerogel are the best materials at the moment, but very expensive and difficult to apply. If you can work with thicker insulations like 30, 40 centimeters, and that doesn't really matter to you, then I think natural materials are an option.
You've mentioned that they're fibrous, so can you just give us a couple of examples of what we're talking about when we say natural?
Well, it might be wood fiber, which is pressed in different plates. It can be very soft, but it can also be fairly hard and dense. It's still diffusion open, but in different degrees. Wood fiber, you can also blow in wood fiber. You have wood fibers which in a different way, like cellulose, which has already been through a manufacturing process and is a waste product. But then you have materials like straw, which I use quite a bit at the moment. I think it's a very exciting material because it does have all these, it's fibrous, it insulates well, it has good water diffusion values, it has some protection against humidity on the what do you call them, these parts of the straw, the round?
I'm not actually sure.
Yeah, well, it's,
yes, those bits.
Those bits, exactly. And they are covered by a protective layer, natural protective layer, because when the straw is growing on the field, you have a very high humidity after rain, and it has to protect itself. In fact, it has a lot of things built in, and it can take big loads. So when you have straw which is compressed, it can take loads as well. There are very few materials and insulations that can take structural loads as straw does.
Does it have to be compressed? And if so, how is this done?
Well, you can press it in bales, like you know from the field. That would do the job, no problem.
That would be airtight enough, just in bales from the field?
Absolutely. This has nothing to do with airtightness. This is just...
the insulation qualities.
Exactly. That's the insulation quality you can get from it. The airtightness you have to do in a different way, and I think that's a tip. We'll talk more in detail about that a little bit later. So what you get is a bale that insulates fairly well. It has maybe 20-30% less insulation value than EPS or one of these materials, so you need a little bit extra thickness maybe. But otherwise it has the advantage of, well, taking the structural loads, and of course after the building will be demolished, you can just put it on your compost heap, and that's it. You can kind of feel good about that as well.
Do you see this progressing a lot in the next few years, or is there a reason that it hasn't taken off? I know in the UK, my wife loves straw, but you have to pay a lot more insurance if you have a straw house.
Well, that doesn't really make sense because the insurance companies, if they look at the data available and you have a straw wall which is plastered with clay, in fact, it will provide a 2-hour fire protection, which there is very few materials that can do at all. So in fact, it's a very, very safe way to build. So many people are surprised by this, but there are various tests being done already in Europe. The Czechs have made one, the Germans, the English as well, I think. In America, they all showed the same results. In fact, when you have densely pressed straw, there is no air to make it burn. It's like putting fire on a telephone book. It's hard work. You have to crush the papers before it really burns well. And when you cover that with clay plaster, which is the other natural material we use in combination with the straw, you have a perfect fire protection.
Does that mean that if a fire has started somewhere that nothing will happen for 2 hours? Is that what you mean by, just to clarify, fire protection?
Yes, in the tests that have been done, you have had 1,000 degrees on the inside, fire going on for 2 hours, and you have been leaning against the wall on the outside without anything happening, no change in temperature, everything fine.
Clay plaster, I'm assuming that's the inside. Is there also lime render on the outside? Is that a common combination? I've been to see one straw bale house. I'm not sure it got to Passivhaus, but that was how that one was.
Yes, straw bale building has been in the hands of self-builders for most of the time until now. And of course, self-builders have been using lime plaster on the outside directly. This works in most cases, if the details have been done properly. It's very important to talk about these details, because if they are not done properly, the water absorption of these materials is quite high, which is the largest danger. So we are in fact looking at some other possibilities to add, for example, a wood fiber board on the outside of the straw and plaster that with commonly available industrial certified renders, which are much thinner.
Are they natural as well?
They are not natural at the moment. So that's, of course, one of the things that needs to be solved. It's always, with natural materials, it's always a problem about getting the balance right between materials that will last long under humid conditions, like the facade or foundation and so on, and having a natural material at the same time and not using any chemicals. There is a trade-off in many places, and there will be for a foreseeable future. But I think there is a huge development going on where natural materials are the basis of innovative products. And I can see that there are some very interesting things coming in the future. The Swiss, they presented at BAU in Munich. That's the big building exhibition in Germany. They presented now a fluid straw. Sounds like funny, but they used enzymes to treat the straw, and when it dries out, it becomes really a very different properties and very interesting properties, and it's a completely natural product. So there are things going on.
So mashing it up. What happens in the foundations then of these buildings, or is that what you were saying, that sometimes you'll just have a concrete foundation to know that that's going to be airtight underneath?
Yes, very often we do use concrete, but there are ways how to do it differently. At the moment we are developing with some Danish guys what they have been doing, in fact, for quite some years. They use mussels in the same way as we use foam glass to make a foundation, and we might be putting some of our ring beams directly onto these crushed mussel or shells.
Really?
Shells? Yeah.
Mussels, as in the sea?
Yeah, but you just...
I was wondering what that was for a second. Thinking, do you mean that? You do mean that?
In fact, it's empty shells, of course, and crushed, and they don't have any water absorptions. They insulate because there is air gaps in between. It doesn't insulate as well as foam glass, crushed or aggregate, like foam glass aggregate, which we use much more often. You can then put a ring beam on that and build your straw house on that and have a safe foundation there. So there are ways doing this. Some of them are experimental. We have used, for example, wooden elements put directly on foam glass for our own straw bale dome, which is our office, in fact. And that works perfectly well. There's no problem with it, but I'm not sure I would do that for our clients yet. So we have to look at who we are doing it for, experimenting with new ideas all the time, and I'm quite confident that you can build a house completely with natural materials that will last very, very long. And it's just getting there, which is a bit hard at the moment. Yeah.
Hemp is another material that I've heard some good things about. Have you any experience with that as a foundation material?
Well, I don't think any fibrous materials, even hemp, would be good in any places where you can get higher moisture content. So for foundations, I don't think it's ideal. You do have hempcrete.
Oh, is that different? Okay, all right.
That's a little bit different. Hempcrete, again, doesn't have a very good insulation value. I'm not saying it won't work for some areas, but it definitely doesn't work to get a highly efficient building from a thermal point of view. So I'm not using hempcrete myself. What I'm using is the best insulation value you can get from the natural materials, and then have the structural thing separately from that, maybe with wood or something, and then using clay plaster just for the plaster part. So with that you can get very far. For the foundation, I think there is a lot more experimenting needed.
We talked about airtightness briefly a while back, and you said we're coming to that later. Can we come to that now?
Absolutely. Airtightness is very important, and it has been neglected a lot by self-builders. Many of these self-built straw houses are very drafty. So when you have a little bit of wind, it gets cold inside, you can't heat it really well, although you have a very well insulated house. And of course, it can cause a lot of damage in the construction. The reason is that any humid air going through any gaps through the construction will condensate somewhere in the structure. And that might be, deciliters per day in some cases. So it can really cause a lot of problems. So what we should look at is have a construction which lets vapor go through the construction unhindered or easily. At the other side, not having any air flow going through the construction, because the airflow would transport a lot of moisture with it as well. And that's what would cause the damage. Now, to achieve that, you can use, for example, clay plaster, which is airtight. But you will run into quite a few problems because the clay plaster has to be connected to wood somewhere.
Why?
You will have a beam going into the wall, for example, so you will, or a stud in front of the wall, and you won't be able to make a continuous layer. Everywhere where clay plaster meets another material, you will get a crack or something like that. It won't last really. Then some movement in the building. You will have electrical installations in the wall. That's hard to get airtight behind that again. So that's a lot of work and difficult to achieve. What we have developed together with the company selling these EcoCocon straw panels is an airtight layer on the outside of the insulation, straw insulation. Of course, first thing I have to say is you never put airtight layers on the outside. You always put them on the inside in cold climates. So anybody listening to this should be aware of that this is not the typical way to do. And it works only if it's also completely diffusion open, vapor open. It has to let vapor go through, and it needs a SD value of less than 0.2 meters to make that work at all. And it should be covered with the wood fiber board, which is able to transport any excess vapor to the outside. So there are certain conditions, but we have done some calculations where we can now build the straw panels, wrap it in an airtight membrane, which is completely vapor open,
and what is that made of?
That's made of, again, not a natural material.
It's okay, it's all right. We'll get there one day.
Yeah, exactly. That's what I'm thinking. It's made of polypropylene or polyethylene, which is fairly well recyclable. So it's no PVC or anything like that. So I think it's fairly harmless. Having a few kilograms of membrane, it's really very thin. And then we cover that again with the wood fiber board. So this opens up the possibilities in the inside. We can easily do the electrical installation, the tubing, the plaster doesn't have to be exactly made. All these things do speed up the building process and makes everything cheaper, and you get a result, which is good. We have had 5 blower door tests now done in buildings like that, all getting below 0.3, which is kind of, I think, a very good Passivhaus result, really.
And on the outside, you mentioned this wood fiber board. Can you just clad it with anything?
Yes, you can put wood panels, ventilated wood facade, or any kind of ventilated facade, in fact. That you're completely free to do that. And if you want to put a render on it, then you definitely need to have a render which has a very, very low moisture content uptake. So the AV value should be 0.1 or something like that, which is in fact all certified plasters for wood fiber boards fulfill that criteria anyway. So as long as you use wood fiber boards and use a certified render, you should not run into any problems.
A little bit earlier in the interview, you were talking about how you might have a timber frame in there or some timber elements. So do a lot of straw bale buildings have that, or can they be structural on their own?
Straw does have the potential to be structural. So you do have several load-bearing straw bale houses. We have our own dome, which has 6 meters in diameter inside, which is load-bearing and works perfectly well. So there are possibilities. The problem is you can't calculate it that easily. So we use usually rather wood. You don't need that much really to make a good load-bearing construction. Fill it up with the straw, or like we do, we use these EcoCocon panels, which are already a combination of straw with wood construction, which you can then use as the structural part and calculate properly. The straw is the added benefit. You get some extra lateral and also, of course, load-bearing capacity.
Are there any other key elements in creating this natural building, or have we covered most of them?
Well, you do have like foundation, walls, roof, and the whole interior, which needs to be from floor cover to plaster and so on. So there is a whole range of materials that can be used to get a whole building made from natural materials. And there are areas where you can get it done fairly easily today. And there are areas like the foundations, which are a little bit more difficult. There are areas of like windows where you do have wood, aluminium windows, but which probably can be separated into different materials later on in the when the building is being demolished. So, but you do have technical installations like electrical cables and so on, which are still wrapped in PVC, and we need to get rid of all this. What is important for me is that materials is a much larger problem for humanity than, let's say, energy. We do have a lot of energy coming down to the earth from the sun. We just haven't learned how to harvest that energy efficiently enough yet. Passivhaus helps us to lower the energy demand so that we can harvest it more efficiently and use more of it. That's why we go into the Passivhaus standard for one reason. The other reason is for the comfort. But when we look at the future, I think the energy crisis will be managed in the next 10 or 15 years fairly easily. But after that, just think about it. Everything around us is being made up from some kind of materials. Mostly there are some toxic materials mixed into this. There are not only 500 materials that are being used in building buildings like they were in the beginning of the last century, beginning of the 20th century. We had 500 building materials that were being regularly used. Today we have about 50,000 different substances being used in our buildings, and we have no idea what's going into these materials. So sorting that out in the long term, that means really having the possibility to put your house on the compost heap or recycling it in a sensible manner, like the aluminium you can recycle forever. Well, that's going to be much, much harder than solving our energy crisis.
Do you think it does come down to population as well? This topic seems to come up from time to time, that we're actually at a stage where we can't have this growing population. Either we as humans make the decisions, or it's going to come to us the other way.
Well, I'm always a positive person, so I think there are solutions.
Me too.
Out there. I think the
send people out into space.
Well, I think we do have technology, and we can apply our brain using natural materials in a much more efficient way than we do today, or all materials for that sake. We do have a huge potential how to deal with this problem. I don't think overpopulation or anything like that is really the core of the problem. The core of the problem is how we deal with that. And just take the cradle-to-cradle concept. Maybe you also know about it, where you don't really try to stifle the consumption, but you try to produce products that can be recycled properly. That means in a technical cycle or a natural cycle. And by having these two cycles working well, you should have no problems having enough materials for our use, also in the future. It's a little bit like a cherry tree. It has a lot of blossoms. In fact, it needs only one cherry to produce another tree, so the rest is all waste, if you look at it. I think it's very beautiful, a cherry tree in blossom. And the difference between how we deal with overproduction is that our overproduction ends up on the wasteland and pollutes, and these blossoms, they fall down and nourish the ground for the tree to grow for the next year. So there is a difference in how we need to change the way we look at this.
Just finally, maybe we could have a couple of examples of houses that you've built and maybe reflecting on their performance, whether the people living in the houses have been happy.
Yes, we do have now 5 Passivhouses, which are built, I think, nearly purely with natural materials, except for the foundations and maybe some of the roof membranes. But they work extremely well. They have perfect comfort in summer and winter. We do have installed ventilation, of course, in all of these. That's part of the Passivhaus concept. So the feeling of these houses is also much warmer because of the materials used. That's a feeling.
I've noticed that before when I've been to straw bale houses, that the acoustic is quite different inside. Exactly. You can still get
much better usually. And it's also because, a lot of times, because of the wood, but also the plaster does. It's definitely better than if you have a brick wall, which is like hard surfaces. And the feedback we have from our customers is very positive. So they are very happy to show other people around in their houses, and I don't have to say an extra word of, they are doing all the marketing for us. So that's really great. So I think even people who have not been thinking about straw houses before, when they see the panels and how flat they are and how nice it looks and how efficient you can build it, then it becomes really very attractive. So yes, the experience at the moment has been very, very positive, and I think I'm really looking forward doing more of it.
Bjørn, thank you very much.
Yes, you're welcome. Thank you.
If you head online to houseplanninghelp.com/89, you can check out today's show notes that accompany this episode, a summary of all of the key points. Also, you can read the full transcript if you want to go in depth, and there are photos, links across to Bjørn, all of the regular kind of stuff. Plus, if you have a comment or question, then you can do that at the bottom of the show notes. So head down there and perhaps we'll be able to bring Bjørn back. houseplanninghelp.com/89. I have an iTunes review to read out. This is from Sam, who's in Norway. My wife and I are looking at doing a self-build, and after being inspired by a straw bale construction in Oslo, Norway, and doing a little research, found episode 22 of House Planning Help, Why Build a House with Straw Bales. One episode and I was hooked. Ben is incredibly well spoken. Oh, thank you very much. What are you saying? I'm posh. Thoughtful and thorough in his approach. I can recommend this podcast to both beginners and seasoned professionals alike, as it covers deep technical issues in a way that can be easily digested without reducing the complexity of the relevant processes. Thanks heaps, Ben. Keep up the awesome work. We love reviews like this. Well, I love them particularly because they keep me motivated, because sometimes it's hard to go through this process again and again and search for new content that we can be creating. So, Sam, I really appreciate that. Also, we've never had a review from Norway before. And so that's why I thought we could target it today. That if you're listening in a country outside where we get most of our reviews, for example, most of them come from the UK. Obviously, that's where we're based. So we're going to attract a lot of those listeners. Also the US and Australia. I think we've had one or two in the Netherlands. So if we haven't mentioned where you are right now, maybe you could jump onto iTunes, write us a review, and then that will bump us up in the iTunes store so that more newcomers find us and hopefully enjoy and appreciate and find this information helpful. So if you could do that, a big thank you to you. Next time, we're off to New York. Builder Darren Macri from Blue Nest is with me to talk about tradespeople. How do we find someone who's capable of delivering us this low-energy building, who's going to do a good job? Is it possible that we can just go, wow, this is the person straight off? So he'll be giving us his advice. I hope you can join me then. Thanks.